Malaysian pause. Yeah, this was two seconds. And to be very to the second. Yeah, might as well. We're supposed to start by 6 and we're 12 minutes in. Really? Ouch.
Hello, good evening, everybody. We're about to start the scheduled webinar. Apologies for the delay, but we had a few technical issues we had to surmount. So we will be commencing in a few minutes, and we thank you for your forbearance. another talk by Dirk van Ossendrop on direct assessment for unpickable pipelines. And in August, later on this year, we'll have our Corrosion Awareness Day, where we plan to run an introduction to corrosion course. As a, by way of information, our sister branch in the Northeast, in Newcastle, I believe, are planning to run their event. The theme is Integrity Engineering for a Sustainable Future. It's running from the 22nd to the 23rd of June. And as you can see, it's quite an interesting array of topics to be presented. More details will be available on the Northeast Branch website.
First day is in the level of the Newcastle, the second day is the site visit around different next
Okay, I've just been advised that's a 2-day event. Day one will be the actual technical presentations, and day two will be more of a sightseeing. But I believe there are more details available on the Northeast Branch website for those who wish to attend. And there is a dinner in the evening, as I'm advised, which would be the highlight of the event, if I'm not mistaken. So, over to our evening session. Our talk today is on maintenance and repair solutions for damaged or aged PFP, passive fire protection. We have with us tonight Dave Wickham and Chris Five. Dave is the technical manager, fire protection for AkzoNobel, and is a chartered fire engineer. And he leads a team responsible for providing technical support for upstream and downstream oil and gas projects, fire protection in the built environment, and also on special projects. Chris is a PFP senior field auditor and coach. He's a surface protection specialist and fabric maintenance coordinator and a chartered scientist, chartered senior technologist, a fellow of our institute, and an AMPP senior level 3 coatings qualified inspector, I believe. Excellent. So without much further ado, I'll hand you over to Chris and Dave to take us through this evening's presentation. Thank you very much.
Okay, ladies and gentlemen, thank you very much for attending this event tonight, and thank you to the Institute of Corrosion for hosting this event. Before I start go through the presentation, I know what questions you're all going to ask at the end of this presentation because I consulted ChatGPT, and they've reliably informed me of the questions I can expect. However, if that doesn't work, I've brought along Chris here, who is our asset integrity specialist, which is not my field specifically. Just to give you a bit of background to this project, it was born out of some inquiries we got in the USA pre-COVID, looking at some damaged PFP on some sites around the Bay of the Gulf of Mexico. And somebody I think it was ExxonMobil, said to me, do you guys provide any repair solutions? So that kind of put me on the track to look at what really did industry need in terms of repair solutions for aged facilities. So without further ado, I don't want this to be death by PowerPoint, so I won't read it line by line, but I think it's fair to say that a lot of facilities, particularly onshore, are aging facilities. They're dragging an extra few years out of, way beyond their design life, particularly with the energy crisis at the moment and the price of hydrocarbons. So there's obviously a very valid economic argument to keep these facilities running for a longer period of time. But the problem is, in the sites I've been to see, and I guess most of you in here probably have much more knowledge and experience than myself, is that some of the PFPs are in a terrible condition, and it's really not fit for purpose. So we need to establish, what can we really do about that? Is it in good repair? You know, has it weathered badly due to age degradation? Has it been damaged, either process or mechanical damage? Perhaps there's been a change of the fire hazard. Maybe different pressures or new items have been added, or new process equipment, or old process equipment have been taken out. So it might change the actual fire scenario. And it can be quite extensive. I mean, certainly in my experience on some of the sites I've seen, you know, there is extensive PFP damage. And I guess in the main, what I've seen is mostly damage to aged concrete and lightweight cementitious, which really has gone way beyond its life expectancy. Obviously, extensive PFP damage is likely to be associated with corrosion under fireproofing, and that might be a bigger concern than the actual loss of PFP itself. And then coming on to the cost side of things, that M&R budgets we haven't all got deep pockets. You know, we appreciate that facilities need to spend their budgets wisely. So what better way than being able to categorize our defects or prioritize our defects, maybe from a priority 1 to some lesser categorization, maybe P3, P4. And the other thing, of course, is that, you know, you have a duty of care to maintain your asset in a safe, you know, in a safe condition. So you've got legislative requirements to meet. So what do we really need to be doing? Obviously, risk-based inspections. We need to be able to categorize the defects. We need to prioritize those P1, etc. And then we need to take into account mitigation measures, be that active fire protection, depressurization, and ability and swift responsive firefighting activities. But we need repair solutions that really have demonstrable fire performance. You know, a lot of people will repair defects with whatever's available, but you know, there may be some doubt about how its fire protection efficacy. So, you know, we really need to look at systems that are third-party verified. And then when we look at economical advantages, it's not just the cost of the material, because the material costs actually may be higher, but it's the installation costs, which can be significant of repairing damaged PFP, scaffolding, you know, the extent of removal of existing fire protection. It can be quite excessive. And we need to be able, you know, your repair systems need to be able to demonstrate. So it's just a technical glitch. So we'll soon be over that. Yeah, and we need to, you know, provide assurance of reliability on these systems. So the next few slides, I'm going to show you what we've been doing at AkzoNobel to deal with these problems of maintaining PFP, aged PFP. My clicker's not working now. This is why artificial intelligence will never work. I remain safe. Sorry about this. This always happens when I do presentations. There's some IT problems. I think I'm a Jonah. Nope, nothing there. We could advance the slides manually if the clicker's not going to work. Well, I think you can probably all hear me. Ah, right. I wonder why I couldn't hear. I couldn't hear my dulcet tones at the back of the room. Aha, we have liftoff. Right, thanks very much for that. Well, the starting point is what we see here. Is a PFP maintenance and repair manual. So, you know, we're looking at these sort of things that, you know, what's it all about? And we deal with these issues that are associated with damaged PFP. You'll see things like PFP over thermal insulation, upgrading of three-sided beams, and solutions for existing paint schemes. They are important additions to this manual, but we're going to really focus on the on number 8, which is the AkzoNobel repair solutions. The manual is in it's complete in a hard copy format, but we're going to be moving it to an e-format, so that basically what a user will do is will key in the defect you've got, the size, the depth, the type of PFP, the type of defect, the fire resistance, and you just press return, and it prints out an installation guide for the products or product solutions that can be used. So this simple flow chart, I think, kind of explains really, if we look at the top, this is our periodic survey, and then we look at damaged PFP. Is it adequate for fire resistance? So what we can do is we can consult our database on damage acceptance criteria. That could be the HSE guidance, or it could be an individual asset owner's specification for repairing PFP. And then it's simply, if we meet the fire resistance requirement, or the PFP is adequate for fire resistance, does it create a dropped object hazard? And if it doesn't create a dropped object hazard, then it's simply a question of does the damage deal with corrosion under PFP? And if it doesn't, if it's not an issue, then we just set an inspection schedule to monitor that defect over time. However, if it doesn't meet the fire resistance requirements, or it creates a dropped object hazard, then we go to this decision here to select an approved repair scheme. And that could either be repair scheme 2A or 2B. So what I'm saying here is that oops, I've lost it again. So what I'm saying here is these schemes 2A or 2B are fire tested for that particular requirement to protect against dropped object hazard, or to reinstate the PFP and address the concern about halting or stop the advancement of corrosion. And scheme 3 might be a special case. We can't cover every particular scenario, so there may be a requirement to do ad hoc fire testing. And most of the manufacturers of epoxy PFPs like AkzoNobel have quite extensive test facilities, so they can do that kind of work specifically for projects. So I'm going to quickly go through some of the repair solutions that you'd find in this PFP manual. I have behind me a sample, which, please come and have a look at it afterwards if you want to. You'll see it's got thermocouples attached to it because it's actually going to be fire tested. It's one of a suite of sections we've got, and it's actually got 2 of the products just to show you what they actually look like when they've been installed. But so we've got a product called Intercoat SFR, which is a structural fire resistant repair mortar. It's jet and pool fire tested. That's the key to it, is offering the customer assurance of performance. And, we're not just saying, yeah, use any system to repair that crack or that defect. We're actually saying, use this system that's actually got fire testing behind it. What you can see here, this is just a section from the manual. You can see a picture of somebody actually installing this material, and there's a concrete encased column. You can see that's had some corner damage, a bit similar to that. But this is the Intercoat SFR is aimed at repairing high density concrete and lightweight cementitious materials. That's the testing that we've done. We would not use this for repairing any epoxy PFPs. And it's what you can see on the screen there is we've done these jet and pool fire tests for over 3 hours. We've tested it in cracks up to 50 millimeters wide, which is quite significant. I would suggest that anything above 2 inches wide, you might be looking at removal and replacement rather than just a repair. Voids up to 900 centimeters squared, and of course Lloyd's UL verified. All of the work that we've done in developing these repair schemes has been witnessed by a third-party organization like Lloyd's or Underwriter Laboratories. We don't have type approval yet. We are applying for that, but all of the application, so it's not just the fire testing, but they come and witness the application and the fire testing. We've got witness statements from these authorities, these bodies. We're not getting an advancement again. If you could just pop it on the next slide, please. Right, that's fine. And this, whoops, go back one, please. Forward one, that's the one. I'm going to get a picture of that. Try going backwards and forwards one and see if the picture appears. Not my night. Should have kept my Amstrad. Anyway, while the technician is trying to sort things out, well, here we go. I always like a picture because I think a picture tells 1,000 words. Anyway, we've got this sample behind us. This is another product. It's an intercoat moldable putty, which has got, again, the testing avoids up to 800 square centimeters. And again, that's all the work we've done has been verified by Lloyd's or UL. You can see that in that picture. This is a column that we actually fire tested at Felling. And you can see the material's red, but on the sample we've got here, it's actually grey. But that's because we've been asked, would we be able to supply it in a different color? Red's a bit too, it tells too many people that you've got maybe a lot of defects on your site. So that's the intercoat moldable putty. Again, the focus of both of these this product as well as the intercoat SFR was being on damaged, dense concrete, lightweight cementitious. And I'll come on to, at the end of this presentation, I've got some slides for some testing that was done very recently in the last 2 weeks. Can we not just sort of, would it putting in presentation mode and just, because it's usually in PowerPoint, there's usually a presentation icon. We are testing a lot of other solutions for damage or non-compliant PFP. Until we might, well, if we're lucky enough to get the slides up, I'll talk about some of the other solutions that we have. We've tested this intercoat moldable putty for grated beams, but for grating on top of three-sided beams. It's very much in development at the moment. I'm kind of maybe jumping ahead a bit, but we've looked at this intercoat moldable putty as a repair solution for, as I said, for three-sided beams where they put gratings on. We've also got solutions, tested solutions again for applying PFP over existing paint systems. So maybe there's a part of the asset that's got a three-coat corrosion system on it, but the fire scenario changes and they need fire protection, 60, 90 minutes, whatever. And we have solutions where you can apply a PFP with an anchor system, so you don't have to blast off the existing paint scheme. And we currently have solutions for 2 of our epoxy PFP products using an anchoring system, which is either metal mesh or friction fitted charlocks. We might have a picture of that. So sorry if I've lost my way a bit. I might be jumping ahead. I'll tell you what, I'll go on to this. There's the solution I'm talking about now, where we're looking at upgrading PFP on existing structure. What you can see there is you've got a three-coat corrosion scheme there, where they've pinned metal mesh to the section, to the flange and the web, and applied Chartex 7 over the three-coat system. So the mesh is actually acting as an anchor in the absence of having a good bond directly to the substrate with SA2.5 blast and a primer. And for Chartex 2218, we have a solution where we just use friction fitted charlocks over the flanges, and it doesn't require any mesh in the web, as long as the web depth is not greater than 250 millimeters. I believe it's 250 millimeters. But these are all tested schemes. We've got a Lloyd's approval for these, so it's not just something that we've come to market with without supporting test evidence. This is the three-sided beams I was talking about, upgrading three-sided beams. These, we actually did some testing, a lot of testing on aged concrete beams, which came from St. Fergus. We were given some redundant structure there, where you can see they have these three-sided beams, just concrete on two sides and at the bottom, and a rain shield on the top, which was heavily corroded. So we've removed that. We've prepared the surface by bristle blasting to ST2, primed it, and we've used two solutions on this. One is the Intercoat SFR, and one is Chartec 2218 mesh free, and they've both been tested as upgrading systems for three-sided. Where you've got a three-sided concrete beam, and perhaps you've got jet fire impingement from above, then clearly you know an unprotected top flange is going to lead to sort of quite a quick structural failure. So rather than reapplying concrete to the whole structure, to the whole beam, we can just apply Chartec 2218 or Intercoat SFR onto the top. Again, these systems are tested. I'll just drop back to dropped object hazard. Again, this is, Chris reliably tells me that dropped object hazard is probably more of a concern than the uncertainty of the PFP being able to perform in a fire. I mean, obviously with dropped object hazard, you could be looking at a fatality in a non-hazardous situation, just when material is badly disbonded and is just not bonded to the substrate at all. So we've got two systems which will feature in our PFP manual. We have a GRP wrap, and then we apply Chartec 7E, which is one of our mesh-free products, literally just at 2 millimeters. And what you can see in that picture on the right, at the top right, is actually it's a fire-tested concrete column. You can see the spalling on the column, and we simply put GRP around the column and then put Chartec 7E over the top. It gives very good fire performance, and the GRP, of course, provides a solution for the dropped object hazard. And another solution for dropped objects is using the Benarx encasement system. I guess some of you may have probably come across the Benarx system, which is made by Bierenberg in Norway. And some of the encasement systems you can see down here at the bottom, where they've encased structural steel, and the one at the bottom, which is a pipe shell over a PFP, a pipe that's got epoxy PFP that's damaged underneath it. But they can be used to provide protection against dropped object hazards. So I'm going to talk. I mentioned the use of this Intercoat moldable putty as a solution for gratings. It is under development at the moment. It works great in fire, but there are some issues about practical application, which we haven't cracked that problem yet. So it is work that's under development, along with a couple of other solutions that Chris has been working on. So we're not 100% sure that we're going to go to market with this yet. It really depends on, as I say, we have to solve some problems first before we can actually say, yeah, we feel confident that you could use this. So I'm just going to quickly go through some trials that we've done with the Intercoat products, the ones you can see behind me. We've done a number of trials. The first ones we did were in Belgium. What you can see here on the left-hand side is a vessel skirt with quite badly damaged, failed lightweight cementitious. You can see it's rotten. You could almost peel it off with your fingers, and the mesh is badly corroded. So this area was about not quite a meter in height by about half a meter in width. And you can see the defective material has been cut away to reveal the existing structure underneath. This was a trial, so the client said, we're not going to concern ourselves with the any corrosion issues. But as it happens, the actual steel itself has only got very, very, very mild surface corrosion. So they were quite happy just to apply the Intercoat SFR over the, just to actually make good the defect. And what you can see here is the application of the product by hand. That's the product there in the corner, in that corner repair. And it's simply mixed with water, and you just use a gloved hand. It's no PPE required at all. You probably would wear a mask, a dust mask, when you're mixing it. You just mix it with water, 10:1 mix ratio, and then you just put it in by hand. You build it up in layers, 10, 20 millimeters, and there's your finished solution. Much harder and much more robust than the actual lightweight cementitious that's been used to repair. But as I say, you can come and have a look at this if you would like to afterwards. Again, this was a trial we did on the moldable putty, the Intercoat moldable putty repair. On the left-hand side, what you can see is this was a 3 meter tall skirt supporting a steam cracker. What they had was a crack running down this the skirt. It's been excavated at the very top because the engineers on site wanted to actually look at the condition of the steelwork underneath. As it happens, it's actually not badly corroded. And then I actually did this myself, but where the crack was probably no more than 250 microns in width, I simply took a scraper and just ran it down the crack just to open it up a little bit. And that's you simply install this material by hand. And that's this was done over a year, coming up to a year ago. This actual defect has been sitting under a fin fan cooler, and it's constantly soaked with water, and it's gone through a full winter in Belgium. And the engineer who goes out there every couple of weeks to have a look at the condition, he said it's discolored a little bit, some dust and is kind of stuck to it because it's a putty type material. But he said the condition of the actual repair is it's just not changed in any shape or form since it was installed. As I say, our assurance to you as potential clients is that we've got all of this work has been verified by third parties, and what we can do at the moment is provide evidence in the form of these these witness statements from Lloyd Register or UL. So all of this work, not just the fire testing, but the application has all been third party verified. And it says at the bottom, type approvals pending. We hope to have type approval from Lloyd's maybe by the end of this year, but kind of getting Lloyd's to do things, there's such a backlog of work, it's not going to happen overnight, unfortunately. These are some pictures I thought I'd show you from the fire testing that we've done. Picture on the left is the moldable putty in a concrete column. You can see it's just an I-section column with 2 inches of dense concrete on it, and there's a 400 by 200 defect cut into the concrete. We put the moldable putty in only at 25, so it's half the depth of the concrete, and then we fire tested it. You can actually see on that side of the concrete the spalling that's occurred, and in the middle you can see that the two columns on the left were concrete. So you can see the middle one is just another picture of the one on the left. The one on the right was a repair with the Intercoat SFR in a similar size defect. You can see it at the top there. The one on the right, as you can see, is a contoured application of a common lightweight cementitious material that's used in industry. And what you can see down here on the left is a machine. I mean, I know you don't get cracks nice and linear like that, but obviously it's for fire testing purposes only. We have tried to simulate more sort of irregular cracks if you want, but for testing purposes, it generates the data that we need. So you can see this is the Intercoat SFR that's being used as a repair in that crack. I'm not showing you all the photographs, we'll be here all night. And these are some photographs of the jet fire testing we've done at DNV site at Spade Adam. On the left-hand picture you can see is an ISO 2000 22899 jet fire box, which is in the standard. The left-hand side of the box has got 2 inches of dense concrete. The right-hand side of the box has got 28 millimeters of a lightweight cementitious material. And what you can see in the repairs, you've got the large 900 square centimeters at the bottom, you've got the 170 square meters defect at the top, and you've got a 50 millimeter wide crack in the center of the jet fire box. And the one on the left is the Intercoat SFR. So on the left, where it's 2 inches of concrete, we brought the Intercoat SFR to the same level as the concrete. And on the right-hand side, since it was only 28 millimeters thickness of lightweight cement, we had the thickness of Intercoat at the same level. The middle picture is exactly the same as the one on the left, but the material you can see is the Intercoat moldable putty. What you can see down there, for those not familiar, is the actual jet fire nozzle. And the picture on the left, sorry, on the right there is, as it says, is the Intercoat SFR post-test after a 3-hour jet fire test. Notice on the left, concrete's completely spalled away. So it's not a failure of the PFP materials, but the concrete. It was actually tested about 3 months after the concrete was applied. So it probably still, we did take cubes and we measured moisture content, but from memory, I think the moisture content was quite high. I think it was still about 6%. So you would expect to see this kind of, this terrible spalling of the concrete in the test. But on the right-hand side, you can see that the lightweight cementitious hasn't spalled at all. Performed very, very well in the jet fire, as you would expect it to, because these lightweight cementitious materials are very good in fire. They just don't have the sort of a longevity that you might expect from, say, an epoxy PFP paint. But you can see that the repair materials of the Intercoat SFR have performed very well. And this is new data that I added just last week. And when I sent the first presentation up to ICorr, this wasn't included because we only did these tests a couple of weeks ago, where we had a 3 by 3 meter corrugated blast wall. And what we've done in here is to machine some cracks. And what you can see, the one on the left is a 20 millimeter wide crack by 0.5 meter long. And this is in Chartex 7E. And this is a picture of the actual material being installed. What you can see is that the person installing that was just running their scraper over the material just to bring it flush with the surface. And on the right, this is a picture post-test of the actual material. You can see, this is the Chartex that's expanded in the fire test. Around the char depth was around about 65, 70 millimeters. And you can see that the actual, this Intercoat mold expanded out as well, but you can see that bit in the middle is gone. That was actually pulled out by us because we were doing a post-test investigation to look at what depth of material was still remaining on the steel. The important thing perhaps to look at is the temperatures at the bottom. If you look at the temperatures that were measured under non-defective Chartex, you can look at the temperatures were about 196 after a 3-hour jet fire test. And if you look at the temperatures on the thermocouples behind the actual defects themselves, you can see not much difference, slightly hotter, but way below the 400 in jet fire testing. 400 C is deemed to be the critical steel temperature. So we're way behind that. I mean, we would have run this on for longer, but they didn't have enough gas to run it much beyond 3 hours. So really good fire performance. And we also we feel as though this material will be used as a gap filler because of its flexibility. So what you've got here is the ISO Jetfire box on the left, and what we've done is we've gouged out some of the. This is a lightweight cementitious material, which is just being used to seal the corrugations. So we've just cut that out for a distance of 0.5 meter and used the Intercoat moldable putty as a crack repair. No temperature measurements here, because what we were looking at is just the integrity of this material to stop flaming penetrating the other side of the actual flame recirculation chamber. I know you can't see it too well there, but this is the actual picture. I mean, it's black because of all the soot from the jet flame, but there was no integrity failure at all on the other side of the jet firebox. So, you know, we're quite pleased with, well, we're very pleased with this performance. Just to sort of summarize the last few slides, in terms of the fire performance, you know, we've put the data for these two Intercoat products into a technical note, a kind of a product selector, if you want. So this is what I was talking about when we mentioned the PFP manual being in an E format. You would key in your details. So it would be what is the size of what is the PFP material? Is it concrete? Is it lightweight cementitious? Is it epoxy PFP? What's the defect? What's the size? What's the fire duration requirement? Is it pool fire or is it pool fire and jet? What's the critical core temperature requirement? And does it meet it? Can we meet that requirement? Yes or no? This has got to be updated with the data we've just generated for testing in epoxy PFP. In terms of durability, what that graph shows you is the Intercoat moldable putty that's been tested under immersion conditions. So 3 months in 5% salt water and in deionized water. So 3 months at 25 degrees, full immersion. And then they were fire tested against the control. And if you can see any difference in those three plots, then I need my eyes testing. There's just no difference. This product has 0 water uptake. It just won't increase its weight by a gram. It's just, you know, it's got an aversion to water. It just won't absorb it at all, which makes it a very resistant. When you've actually got it in defect, it makes it very resistant to water penetration. But that to me is a phenomenal result. And the work we're still doing, these products are not quite launched yet. So we're still doing testing. There's products under cyclic testing going on in ISO 12944 at the moment. So we're also testing to see what temperature resistance it can tolerate. So we're down at -60 and I believe +60 at the moment. We're going to be looking to get that up to maybe testing that as high as 100 degrees, maybe hotter, I don't know. The Intercoat SFR, this complies with EN 13687, which is a standard more for concrete repair materials. So obviously, if it's going to be used mostly for repairing dense concrete, then it can impart the same performance requirements that you would expect the concrete itself to actually show. But that testing, which I fully admit, I'm not fully au fait with that standard, but it covers the requirements for freeze thaw, saltwater immersion, and thermal shock, and dry and wet. And it's currently under test at the moment to ISO 12944.9, as I mentioned, and also the ISO 2812, which is the seawater immersion test, and ASTM D5894, which is, I believe, salt fog testing. I'll put my hand up and say that I'm not an expert in these durability standards, but obviously we've got chemists in the lab that who deal with these kind of tests. And I think, kind of to summarize, you've seen a lot of data, you've seen some pictures, you've seen a sample here, but the repair materials, its application simplicity is what people are looking for. The Intercoat moldable putty is a one-component moldable material. It comes straight out of a plastic bag. It's completely non-hazardous. It requires no PPE. It doesn't require skilled applicator. See, if you're using this offshore, you don't need to helicopter out an approved PFP applicator. Anybody can install it. All they're going to do is follow the application guideline instructions. No tools are required. It's applied just using your hand, as you saw from the picture. And it's because it requires no hot work permits. There's no, unless the client actually calls for surface preparation work, there's actually there's no tools required, so you don't need any hot work permits. And also for the Intercoat SFR, as I said, it's a one component structural grade repair mortar, and it's mesh free. Again, it's non-hazardous. You don't require PPE. As I say, perhaps a dust mask when you're actually mixing it. And it can be applied by hand. You saw in that picture where they were doing the application to that vessel skirt. You actually apply it with a gloved hand and build it up in the right thickness. Again, you don't need any hot work permits. So what we're really saying is that if there's a demand for these solutions, it's the application simplicity. You could, particularly with Intercoat moldable putty, you can imagine people working off rope access and just being able to repair a crack or a defect without having to, complicated removal and reinstatement. They can just use this material to effect a repair. So in summary, before you start firing the questions at me like a machine gun. Sorry.
Just on the last slide up there, I think if you accept that an asset's health measured from the asset integrity register, the ability to recategorize these at source. So if you can consider a rope access inspection technician identifying a defect in the material and the ability to repair that material in situ as he's inspecting it, it doesn't enter, that defect doesn't then enter that asset integrity database. And not only that, you could identify several defects in several locations and rapidly close them defects out, significantly reducing the amount of defects in the database. And like Dave said, the simplicity in the application, there is no training for it. Pretty much anybody can do these repairs.
Yep. Just got to follow the application guidelines, and they're as simple as they can be. So yeah, thanks for that, Chris. Oops, going the wrong way. So yeah, just in summary, I hope you agree with what you've seen today, that we think we're bringing something to the market that the industry needs. But at the end of the day, the acid test is what people in the industry tell us. Yes, these products are going to be useful, or you need to make some modifications, or can you consider this particular problem that we've got? So, I need to update the manual and the installation manuals, because we've now got this this application to epoxy PFP. And if we look at this application simplicity, this is the thing that it bites at me all the time, because it's the real gain, it's the real unique selling proposition for these two products. It's just really how it just changes the whole landscape of doing PFP repairs. There you go. I know there's a lot I've covered. But if any of you or any of your colleagues at work have got any queries or anything about what we've talked about today, there's our email address. Please get in touch with us. The products aren't launched yet. We're very close to it. We're hoping they might be commercially available by the end of June. That's a hope anyway. But obviously these products have to go through quite a rigorous approval regime within the company in terms of regulatory affairs and the formulations and all that sort of thing, which is not my area. But yeah, please get in touch, and I hope it was useful. Thanks for attending, and thanks for the audience that have dialed in remotely. And once again, thanks to the Institute of Corrosion for hosting this event and allowing us to come up here and talk about this today. It's been most appreciated.
Thank you, Chris.
Thank you, Dave. Thank you, Chris, for a very wonderful presentation. I'll take questions from the audience first, and then subsequently handle the couple of questions that we have online. please wait for the microphone before asking your questions so the guys online can hear questions as well. So any questions from the audience, please?
Right, thanks, David and Chris, for coming up from Newcastle. So quite a drive for you. So very good and excellent presentation. Thank you. Just going to ask, have you had any external funding at all? Is it entirely AN funded, this research?
Oh, it would be nice to have some external funding. No, unfortunately not. And, you know, these jet fire tests, what with the price of gas and I think that bulkhead jet fire test was of something, because it ran for 3 hours, probably cost about 28 to 30 grand.
Okay.
So unfortunately, we haven't found an what is it, a knight in shining armor who's got bucket loads of cash to give us, but so yeah, we've had to fund it ourselves, unfortunately.
No, I just wondered if you'd approached NZTC, you know, Aberdeen, what used to be Oil and Gas Technology Centre, OGTC, in Aberdeen, whether you'd approached them at all. But
No.
No.
All self-funded,
very impressive. Thank you very
very
much.
expensive.
Thank you, Steve. Next question.
Yeah, thanks, David. Chris, thanks. So where do you see the main target application for this this material? I mean, is it on sort of bridges or offshore platforms, or where do you, which is your main?
The concept came about from the offshore, the oil and gas side of the business. Typically, I mean, historically, I would say there's been a lot of cementitious material being applied over the years. Latter years, it's turned to epoxy, but it's mainly stemmed from the ability of, let's say, to do something a little bit different. If you look at fabric maintenance campaigns, they can be quite expensive, quite onerous, and quite lengthy. Where this material looks at that a little bit different. It may be, let's say, you might have a campaign happening in 3 years or 4 years' time where you have that budget available at that time, and many of these systems can be used to defer that repair until that time. So some instances you could say, is it a permanent repair or is it a temporary repair? I would say it's probably for the next inspection frequency. Let's have a look at it, see how it's performing. But certainly you could plan it in for a more, let's say, a campaign that had been planned.
Good, thank you.
Yeah, the materials that you apply to these cracks and that, are they bonding to the actual cementitious material and concrete? You know, what sort of bonds do they form? Or is it mechanical? You jamming it into these cracks and smoothing it over without any pressure?
Yeah, well, for the Intercoat SFR, because that's obviously mixed with water, it's got a high water content. So when it's used as a repair to, because it won't be used for epoxy PFP, but when it's used as a repair to lightweight cementitious or concrete, then you have to moisten the adjacent concrete or lightweight cement so that it doesn't rapidly dry out. It doesn't suck the water out of the intercoat and cause some cracking or disbondment at the edges. So yeah, you know, it develops a strong bond with the adjacent lightweight cementitious or concrete, but it also has a good bond to the steel. We're actually promoting the system on top of a surface tolerant primer. We're making the assumption that in most cases, clients, or especially with concrete lightweight cementitious, the defects will be associated with a degree of corrosion that can't be left, and that it'll require some form of preparation like bristle blasting or power tool cleaning, and then we use a surface tolerant primer, and then the Intercoat SFR. I mean, feel free to come and have a look at this afterwards, but you'll see that the Intercoat SFR has got an extremely strong bond to the concrete. It's much stronger than to the lightweight cementitious. You know, it's, I don't know what the shore D hardness would be, but it's probably significantly higher than that lightweight cementitious material. With regard to the Intercoat moldable putty, one of our lab technicians took a 1 inch square approximately of this 24 hours and came in and picked the thing up with just a small bit of putty on it. And the putty actually started to stretch, started to elongate. It didn't disbond from the steel. So the putty forms a very strong bond with this steel substrate.
Suppose rebar or steel within the concrete, you're cleaning that
Well, we don't use,
rust back or?
well, we're not actually using it yet as a repair material for structural concrete that's got
Right.
rebar in it. It's just for concrete that's being used as a PFP material. Typically on, say, downstream facilities where the first 3 meters of columns on a pipe rack, say from grade up to 3 meters, will be dense concrete purely for mechanical damage, from forklifts and the like. So it's, it's focused on concrete that's used as a PFP material as opposed to structural concrete, which would be mostly the Intercoat SFR, which is actually a structural repair mortar with very good fire resistance properties. So, yeah, we haven't moved that there yet.
Other materials in there.
Yes, there is. The manual talks about other products that we can use for repairing structural concrete.
Very good, thanks.
Thank you. Any more questions from the audience? Excellent.
Hi, Chris. Dave, thank you for a good presentation. Question, has it been tested for blast overpressure?
Not yet. Work in progress.
I'm thinking mainly of the lightweight cementitious material. We know that is vulnerable to blast overpressures.
Yeah.
So
No, that's right. I mean, all the products we bring to market, we have to have, these days, we have to have fire performance, we have to have blast performance, and we have to have cryogenic performance. If it's going to be used in cryogenic applications, LNG or these days, maybe even in where we're protecting hydrogen assets. So we haven't done that work yet, but blast we have work requests in to test it on circular hollow sections where they've been repaired with the intercoat materials, and they'll be subject to a 3 or 4 bar overpressure blast test. But at the moment, no.
thank you.
Thank you very much. Any more questions from our audience? Right, so I'll move to the online questions. We had a couple. So I'll read them out. Our first question is from Graham Kennedy. And the question goes, can the repair materials be used when the temperatures are low?
The application temperature.
I believe that's it.
Yeah. Well, the intercoat moldable putty can be used in any temperature. There's no temperature limitation at all on what you would expect in a variety of climates, from Arctic to very hot and humid. As long as I think what Graham is asking, is it subject to the same humidity requirements and the formation of a dew point that you would expect to have to follow with a wet coating? But for intercoat moldable putty, there are no temperature limits in terms of the ambient application temperature. For intercoat SFR, we state that the product should be protected after it's been applied. It should be protected from rainfall or high heat for a period of time, so one, it doesn't rapidly dry out, or to get an early soaking. But apart from that, those are the only limitations at the moment on ambient application conditions.
All right, thank you. Our next question goes, what will the impact be on repair due to blast overpressure? I guess we've touched on that already.
Yes, we have touched on it, and we have no data on that at the moment, but as I say, that's a work in progress. We're going to launch the product before it has that data, but obviously where there is a blast requirement, then we won't be able to meet that. It does raise the question of what repair solutions out in the marketplace do have this kind of fire performance data, durability data, and blast performance behind it. So, we have to learn to walk before we can run, but in terms of the the money that we have to spend on testing, we have to prioritize what we need to do first. But blast testing, as I said earlier on, is very much work in progress.
Thank you, Chris. Sorry, Dave.
I've been called worse.
Our next question goes, can these products be applied as PFP itself rather than just being used to repair local PFP damage?
No, we haven't got that kind of test. It's not or epoxy PFP. The closest we've got to that is the pictures I showed of the intercoat SFR being used to upgrade concrete beams, but we haven't and don't. It's purely focused on M&R's repairs.
Okay, thank you, Dave. Our next question goes, have you tested the repair putty along with lightweight motors in all fire scenarios, including pool, jet, and blast scenarios? And then the second part of the question goes, does AkzoNobel guarantee the integrity in such repair scenarios, even if a third-party product was used?
Sorry, could you repeat that bit again,
Okay.
please?
The first part of the question goes, have you tested the repair putty along with lightweight motors in all fire scenarios, including pool fires, jet fires, and blast fire scenarios? And then the second part of the question goes, does AkzoNobel guarantee the integrity in such repair scenarios, even if a third-party product was used originally?
Well, the first part of the question is lightweight mortars. Well, to me, that indicates something like that might not be an original PFP material, because I haven't come across a lightweight mortar material, unless the question is referring to lightweight cementitious materials.
I believe so, yeah.
But yeah, if it's lightweight cementitious as opposed to lightweight mortars, then yes, we've done significant testing in lightweight cementitious, two commonly available ones. In terms of the last question about the longevity, the guarantees, we can guarantee the fire performance in the scope of what the testing, within the scope of the testing we've done. In terms of assuring its longevity, as Chris said, these products they have a defined life. They're not intended to be a 25-year repair to any PFP out in offshore or onshore. They are there as repair solutions until such time as the budget allows for, or till they degrade to a point where the PFP is so badly damaged, the only economic solution is full removal and repair.
I think just to finish on that, AkzoNobel, as with any PFP manufacturer, doesn't guarantee the application. That is very much down to the people who are applying it.
I would like to add on that point, Chris, that's a good point Chris raises. You do not need specialist applicators or training. All the person who's installing it needs to do is follow the installation guide. And believe me, that's a simple one-page document. And honestly, it's I keep saying application simplicity, but that's what it's about.
Okay. Thank you, Dave. Next question goes, do you have any solutions for epoxy-based PFPs?
As I say, in the last 2 weeks, we've done some initial testing with one of our Chartec products on a blast wall. So we've got some further testing to do, but we have generated the first jet fire test of using the intercut moldable putty as a repair to epoxy PFPs, as I say, for cracks up to 20 mil wide. So we've tested the two crack widths, 10 and 20 mil, and the product performed very well. But we want more data. That's one jet fire test. So we're currently doing, I believe next week, we're doing some more tests in the furnaces at Felling to generate some more data on slightly bigger defects. So I think we're testing the moldable putty in a Chartec crack at up to 50 mil wide. But somebody said to me, if you see a crack in epoxy PFP 50 millimeters wide, something's gone very wrong.
I think it's also just to expand on the answer to that question is, yes, we do have other materials that are suitable for epoxy repairs. It hasn't been presented yet today. It was, they're on the market, they're quite commonly known products. Mesh-free, surface-tolerant, simple repair systems for epoxy systems, but they haven't been presented today. This is just like a new offering, an additional tool in your toolbox to say these are solutions to various problems, but AkzoNobel and the maintenance manual does cover them other areas.
All right, thank you. We have a question from Bryn Roberts, or rather a comment from Bryn Roberts. Interesting and well-detailed presentation. Well done.
Thank you. Thanks to Chris.
And a question from Philippa Nigola. How well do you expect Intercoat SFR product to perform when used for repair of culverts?
Yeah, I'll let you, but yeah.
And something, but would you fireproof a culvert? I don't know.
Maybe a dike.
I don't know. I mean, do we have fire protection applied in culverts? I don't know. And again, it goes back to the gentleman's earlier question on repair of concrete, structural concrete. This is not designed to do repairs in structural concrete.
All right. Thank you very much. Next question. What kind of substrate fabric maintenance is required before applying these products in situations where a steel substrate is corroded extensively?
Any remedial works, Chris can hopefully support me on this, but any remedial works in terms of the degree of corrosion is an assessment the client needs to make. We're recommending that these products, we've tested them without this surface preparation. We've tested it on corroded substrates, and we're doing more work. But we're going to recommend, as a general recommendation, that the substrate would be prepared to an ST2 standard and then primed with a surface tolerant primer. Doesn't have to be an AkzoNobel surface tolerant primer, just any approved surface tolerant primer. And then, the products will not halt corrosion. Sorry, they won't prevent corrosion, but they'll stop the rapid advancement due to moisture and water getting through to the substrate. But we would recommend that a suitable surface preparation and priming would be done depending on the degree of corrosion. But that, as I say, would be an assessment the client would have to make when they're doing their inspections.
I think it's worth remembering, once you've got corrosion under fire protection, it tends not to be focused in a specific area, maybe a more wide-reaching phenomenon or problem, and therefore further investigation would be required. And then these, let's say, localized repair systems may not be the solution in that situation.
All right, thank you very much. We have a question from Muhanin Fegia, and the question goes, what are the limitations for this application product?
The limitations, as I've mentioned earlier on from the question from Stephen, is that the limitations are bounded by the physical defect size that we've tested, but also any parameters, application parameters, maybe extremes of temperature or extremes of humidity. We've already established the temperature limits based on the testing we've done, but we're extending that testing to try and push the boundaries of temperature tolerance higher. So we're still doing durability testing to this day, and we'll continue doing durability testing to the end of this year to actually finalize or to be quite be more specific on what are the temperature or what are the application parameters that can't be accepted, which we will see a noticeable loss of performance. So at the moment, a lot of that is work in progress at the moment. But we do say currently in the installation guides what the limits of the testing we can support at the moment.
All right, thank you. And our last question online goes, can it be used on wet surfaces in saline environments?
We haven't done any testing of applying it to a wet substrate.
Maybe the SLR, and because you've got a wet. both
Yes,
sides.
yes,
But when we talk about the saline, is the question, you know, does the existing substrate contain a lot of salts? And that's what we haven't tested. You know, the expectation is that that area will be flushed and cleaned of those salts. If there's any, let's say, salts within that existing system, then, you know, you can't chase it back to find out to a point where they don't exist because you're extending the defect and then it's no longer the relative material.
All right. Thank you very much for the answers to these questions. So once again, would like to thank you on behalf of the Aberdeen branch of the Institute of Corrosion, and I wish to invite our audience to show their appreciation with a round of applause for these wonderful answers to these questions. I would also like to invite our president, Steve Tate, to help me with the presentation of these certificates. So I appreciate for you guys giving us this presentation today.
Very much appreciated you both coming up, and again, an excellent presentation, which I hope you'll convert perhaps to a technical article in the magazine, if you'd like to consider that. Yeah. Thank you very much indeed.
Thank you, everyone. So our next technical presentation will be the last on the 20th.
Last Tuesday in June,
27th of June. Thank you, Steve. A talk by Dirk Van Olsendrop, and we look forward to seeing you guys there. Have a lovely evening. Thank you.